Hey everyone, welcome to Enigma's Git and GitHub workshop. Today we'll be covering some basic Git and GitHub commands using the terminal. And if you don't know what those words mean yet, don't worry, that's exactly what this session is for. Git is all about version control, keeping track of changes in your projects, like saving different drafts and all that. And with GitHub, you can take those projects online, work with others, and even participate in events like Hacktoberfest. So, all that you have to do for this workshop is grab your laptop, open your terminal, and we can get started. If you're a Mac or Linux user, you don't have to do anything more. But if you have Windows running on your systems, check the description below. There'll be some more instructions for you people. So let's get started. So on the terminal, the first thing that you're supposed to do is install Git and GitHub command line. I'll type those commands in. So after running these commands, you can check if Git and GitHub are actually installed on your devices by running these commands. And obviously, once you install them, you don't have to install them again and again. Then I would like you to run two commands that are supposed to be run only once. Like you don't have to run them again and again. But you would understand its true meaning later on when we actually deal with these things. But for those who are already into Git and GitHub, what I'm trying to do here is using the first command, I'm trying to rename the initial branch to main. If you do not know what a branch is, no worries. We will tell you what a branch is. If you do not do this, the main branch, the original branch is going to be called master instead of main. And we're changing this because the current convention is to have the initial default branch to be called as main. The second command is used for visualization. We will use this much later on in the session, so you do not have to think about it much now. Moving on, we'll first create a folder on our terminal. So there's a Linux command called mkdir that creates a folder for you and you name your folder after it. So I'm calling my folder local folder. So how do you check if your folder is actually created or not? There is a Linux command called ls. It lists out all the folders and files in your current directory. So you can see there is my local folder over there. Now I would like to get into the local folder. So in order to be able to do that, there's a command called cd. Cd means change directory. So directory, repository, folder, these three terms is something that I'll be interchanging and using. And pro tip, you can use your arrow keys to go back to the previous commands. Arrow key up and arrow key down. And if you would like to use autocomplete, there's the tab key that you could use. I'll show you where you could use a tab key. For example, if you would like to go back, you do cd dot dot, so it will take you back to the parent folder, and I could click ls and see I came back to where I was. So let's say I want to go back into my local folder again, cd loc. Now I can press tab to auto complete my folder name and then click enter. Now that we are in our experimental folder, let's start experimenting. So first I would like you guys to create one more folder. So I'm calling it test. So let's see if the folder is created. It is there. So I will cd into my test folder. If I do ls here, nothing will be there because this is an empty folder. But then if you would like to look at hidden files and folders, you'll have to add the a flag. So ls-a. So you see dot and dot dot. Dot represents the current folder and dot dot represents its parent folder. So if I do cd dot dot, I will go back to its parent folder. Right, so let me go back to my test folder. So the first command we'll be running is git init. So this initializes git. So you will notice the change if you do ls-a. So there is a dot git folder that is created. You do not have to enter it. We will have to just leave it as it is. But there's no harm in exploring. So I just cd'd into .git and there are some bunch of things over there. So you do not mess with these things. You just leave the git folder as it is. So I'm going back. So git init will initialize git. Now I will be able to use git commands and whatnot in my test folder. So the git config local username and git config local user email will let git know that this user with this email ID has a GitHub account. So essentially that. So whenever we'll be dealing with GitHub commands, this configuration will let git know that there is this person with so and so username and so email ID. And the local means this credentials works only in this repository. If you want it to work across any repository on your device, you can change local to global, which would look like this. Right? You can do this. So the next command that we'll be running is gh-auth login. So this is your first GitHub command. Gh is GitHub. So now it will ask you a series of questions. You're supposed to answer them. The arrow keys will help you navigate between the options. So our first option is github.com. We'll be using HTTPS and we'll be logging in with a web browser. I'm clicking enter to choose the option and click enter again to open the browser. So after you clicked enter, a new browser window appears and then keep following the instructions. So if you press Alt tab, you'll be going here and then 0C5. The code is here. Click on authorize GitHub. Alright, if you're not logged in, it'll ask you to log in. So we are done with the browser. Now we've successfully logged in to our GitHub as well. So you can run all GitHub commands on your terminal. Now we've completed the installation and authorization process. Now we can start with the actual Git and GitHub workshop. So the first thing that we'll be doing is creating some files. So we are currently in our local repository called test. I keep telling local because it's on a device. It cannot be accessed from anywhere by any device on the internet or wherever, or any device that is around you. This is on your device. It's a local repository. When we deal with GitHub, we will talk about folders that are stored elsewhere, but you will still be able to access them. So GitHub will deal with all those remote repositories. So right, so our first task is to create some files. So in order to create a file, there's a command called touch. So I'll create some files. So if I do ls, I'll be able to view all the files. We will be able to access these files through the terminal using text editors like Vim or whatever, but then that would make it a bit difficult for beginners. So I will be opening the file explorer and opening these files. Local folder, test. So I have my files here. So I would like you guys to populate these files with some random text. So I've populated the text files. Now we can run the next command, git status. It says our four files are untracked files. So untracked files are not tracked by Git, in the sense whatever changes you make in them, they they would only store the latest version, and you will not be able to store the previous version of the file. And the whole point of Git is to be able to store multiple versions of the same file. We will see how to store multiple versions of the same file. Meanwhile, if you notice the first line, it says on branch main. So it says we're currently on the branch main. By default, Git would say master. So if you remember, I asked you to run these two lines, right? So here the first line changes the default from master to main. The second line will come to it later. Next, we are supposed to somehow track these files. So the first step to tracking these files is using the git add command. And if you immediately run git status after that, you will be able to see f4 is the only remaining untracked file, whereas the other three files are under changes to be committed. So technically the files f1, f2, f3 have been staged. So we are preparing these files before committing them. And commit means you're going to store uh, the snapshot of your entire staged files as a particular version. So later on, if you modify f1, f2, f3 as well, uh, you will still be able to return to the version that f1, f2, f3 are in currently. So in order to finalize the changes, we will run the git commit command. So the -m signifies message. So first commit is a message. You can add as many number of -m's you want. The first -m would signify the main message, and the remaining would signify description of the commit itself, a more detailed description. So if you run git status again, you will see f4 is still untracked. And since the staged files have already been committed, those files will no longer be shown in git status, but it doesn't mean they've disappeared. You can always run ls and see that all files are still over there. We can run the command git log to see what commits we've made. But in order to have a visual representation of the commit tree, there is a command called git tree. Git tree is not a default command. Uh, we ran one line before. So this line created the command called git tree. So git tree is an alias for some other thing. So the some other thing is the visual depiction of the commit tree on the terminal. We just aliased it into one single word called tree to make our lives easier. So the tree will take the form of a tree when we have more commits and so on and so forth. So we have now seen how to create files, stage the files, and then commit the files. Let's try making another commit after modifying the contents of some of these files. We can run git status to check the status. Two files have been modified and F4 still remains untracked. Let's say we want to add all the files. So instead of typing all of the file names, you can just write git add dot, and now we can check git status. So two modified files as well as a new file have been staged and they're ready uh, to be committed. Now if you notice, there is nothing to commit. Working tree is clean. So no staged files and no untracked files. And if I run the git tree command, we are displayed a visual representation of the commit tree. The bottommost line being the first commit, and every other new commit will uh, appear on the top of the git tree. And git log shows us the history of commits that we've made, oldest one being at the bottom and the latest one being at the top. But let's say you want to undo this latest commit and you want to do something else. So you'll be running this command. So if you notice, we came back to the previous version where F1, F2, and F3 have the same lines, and F1 and F2 do not have the new lines. And if I do ls, F4 has disappeared completely. So it has completely undone the previous commit. And since F4 was untracked in the first commit, Git did not take care of that. So now F4 is completely lost. So you have to be careful whenever you perform such deletion operations. If you look at one of the git log outputs, here you can see commit and a long string of alphanumeric characters. So this is the name of the commit. So it's some hash value. And if you look at the output of the git tree, you have the first few characters of the uh, hash value of the commit, because uh, none of the hash values of any two commits would usually be the same. So taking the first few characters would be sufficient to distinguish between any two commits. And you have something called head and main. So we've seen how the output of git status says on branch main. So you can think of branch as a pointer to a commit. So this main is a branch that points to this commit currently, and head is the pointer to the commit that you currently are on. So since we made a new commit, head will since we made a new commit, we will automatically be in that commit. So head will be pointing to the latest commit. And I told you, topmost is latest and the bottommost is the oldest. So you can keep these things in mind, head and main being pointers to a commit. So main is a branch, right? We can create multiple branches. We'll come to that in a while. Let's modify some files once again. So I've added all the files. So all my files are staged. But let's say you want to unstage F3. What do we do? Then we run this command. So if you notice, after running git status, we can see how F3 has gone back to being red in color. So Git recognizes the file has been modified but not staged for commit, and the changes made to the file have also been preserved. It was only because we used the staged flag. If this was not there, it would have undone the changes and F3 would have gone back to having only one line. For example, I can show it to you right here. So if the staged flag was not there, it would restore F3 back to its latest version, which was its original format only, first time here. You can only create versions if you commit the changes. So you have to stage the changes first by using the git add command and then git commit the changes. So currently F1 and F2 have changes and they have been staged as well. So I can peacefully commit these two files. So if you notice the git tree, we've created a new commit and we are currently in this version. So head is pointing to this commit and we're on the main branch. So that's how it is, pointing to the same commit. We can now create a new branch using the git branch command. So if you notice the git tree, you can see how new feature is pointing to the same commit because we are currently on this commit and then we did git branch. So new feature is another branch pointing to the same commit. In order to shift to that branch, we use the git checkout command. So now if you notice, after running git checkout new feature and after running git tree, you can see how head is pointing to new feature because we are currently on the branch new feature, and head will always point to the commit that we currently are on and the branch we currently are on as well. It differs from the previous git tree output, you can notice. Let's create one more dummy branch that we can delete in future. Since we are currently new feature, let's add a new feature by modifying some files. So I created a new file while being on the branch new feature. So if I run git status, it recognizes F4 as untracked because it was newly added. So I'll stage and commit the file. So you can look at the git tree output and realize we've created a new commit. And if we create a new commit, our head will always go to that latest commit. And since we were on branch new feature is now pointing to the new commit. Meanwhile, main and dummy are still behind, pointing to the same old commit. So I've printed out the contents of each file in this current version, new feature. So if you we can look at the previous versions of the files if we go back to the previous commits. So I will be able to go back to the commit right before this using either main or dummy. So let me git checkout main. So I'll be changing my branch git checkout main. So currently I'm on main. You can see head has changed to main. Now let me try printing out the contents of F1, F2, F3. If you notice, it says F4 is not a file in the first place. We can confirm by doing ls. So you can notice how the current commit and the latest commit are different. In this commit, we have an extra file. In this commit, that file does not exist in the first place. And this need not be limited to multiple files. You can have lines existing within the same file in different versions. I will show you an example. So on the dummy branch, I've modified file 2. I've added this extra line. You can see I've printed it on the terminal as well. And F4 of course does not exist on the dummy branch. So I'll stage the changes and commit it. So you can see how the tree is taking the form of a tree, right? So it looks like this is one branch and this is one branch and something like that. But this is a commit tree. So the commit is taking the form of a tree. Branches are just pointers to each of the commits. So there's a main branch, there's a new featured branch as well as a dummy branch. Head is a pointer that shows where we are currently. So we're currently on the dummy branch, which is pointing to this commit, the dummy commit. So I will go back to a previous commit, which main is pointing to currently. So git checkout main, and now I shall print out the contents of each of these files. If you notice, it does not say I'm on the dummy branch. If you notice, file 2 does not say that. This is an extra line. This is not saying this. Why is that the case? Because we know that line was not added in this commit. That line was added in this commit. So this is the latest version. The older version cannot have the new line. That is very much obvious, right? We went back in time essentially. You can even bring up the analogy of timelines. Let's create another branch. So there is a shortcut to creating a branch and then checking out onto it in just one line. So I'll write that right now. So this one liner does what these two lines do. Git branch special feature, git checkout special feature. In one line you can create a new branch and then check out to that branch. And if you notice, while we were on main, we created the new branch, so special feature will be here. And since we checked out to it as well, head will be referring to special feature, and we'll make some modifications now. So I've done some special modifications in a certain file. Which file? File 3. Okay. So if I run git status, it will show F3 has been modified and they have not been staged yet. So I'll have to stage them. can write git add dot or you can write the file name as well. And I'm pressing tab to autocomplete. So it has been staged, and I shall commit this with a message. If you do it without hashem, then it will open a text editor and you're supposed to type a message, because by default it forces you to give the message for each commit. There's an option to turn it off, but that's not good practice. You're supposed to provide messages for every commit. Now the tree is starting to look like a tree, right? You have multiple commits, so each of these stars are commits. You have dummy, new feature, main, special feature. So now let's think about deleting a branch. So how do we delete a branch? So I'll run this command that deletes a branch, and this will only work if you're not checked out on the branch. So I will delete dummy. Since I'm on special feature, the command that I'll be running should work. Right, we'll come to what merging is in a while. But if you notice now, the branch dummy is gone. It's no longer there. Now I said I'll talk about merge in a while, right? So the time has come. So let's say you want the changes in this commit version and the changes in this commit version to be together. So you want one more version where the changes in both these versions are present. How do you do that? So the term here is merging. So you would like to merge these two commits. How do we do that? Currently we are in on the branch special feature, right? The head is pointing towards special feature. So we are currently on the branch special feature, which again is pointing to this commit. So in order to merge some other commit with our current commit, we have to write git merge and the other commit's name. So you can either provide the hash value or you can provide the branch name that points to the hash value. So I can either do this, or I can even provide the hash value. So let's say I give in the hash value. So on the terminal, control C and control V wouldn't serve the right purpose. You're supposed to do control shift V and then control shift C and control shift V, and this should work. And you're supposed to provide a commit message as well. Since I didn't provide it in the terminal with a hash m, it opens a text editor, which most of us find dreadful, at least for the beginners. So this is the commit message. So I'm just pressing Ctrl X to exit. We should have provided the merge message here itself with a -m. Now if you notice, previously we were on the branch special feature. We still are on the same branch, but we've merged the features of this commit and the previous commit, which was right. So we've merged the features of new feature into special feature, and then it created a new commit. You can see the numbers. It created a new commit, and since we created a new commit, head will go to that commit. And since previously we were on the special feature, now special feature will point to the new commit as well. So previously special feature was pointing to this 6EA. Now it's pointing to 5F, 6F. 6EA is no longer pointed to by any branch. Now our new commit has all the features of this commit as well as this commit special feature. We can test it by printing out the contents of each file. If you notice, these lines were added in special feature, while file 4 itself was added in new feature. In order to verify my claims, we can always git checkout to the previous commits. So one of the previous commits was new feature, and then we can print out the comment contents. File 3 doesn't have the new lines because we know it was added in the special feature commit. And since there is no branch pointing to this commit, I will have to give the hash value itself. Control Shift C, Control Shift V. And interestingly, now if I print git tree, you will notice head is currently here because I checked out to this commit. So this is the first time you're seeing head not pointing to any of the branches. Right. So why did we come here? We wanted to look at the contents, right? Here, if you notice, it was on this commit that we added these new lines. And file 4 does not exist at that point because file 4 was added in this commit. So it's like two different versions of our same project or whatever you call this, the test folder. Finally, we are merging these two different things into one thing, which is currently a special feature. So let me git checkout into special feature. Right, so it has both this line as well as this line. So merging also creates a new commit. So if you want to undo the merge, then it is essentially undoing the commit itself. So, and when you undo the commit, the changes would be removed. But since we are simply merging, there's essentially nothing much that is going to disappear completely. Like the first time we deleted a commit, we lost the file f4, right? But here everything is staged and committed, so there's nothing that we'll be losing. So let me undo the merge, which is essentially the same as undoing the commit. So now if you notice the merge, this one just disappears. We only have a new feature, and our special feature has gone back to the special feature commit. No data is lost because all the files have been staged and committed within their respective commits, unlike the F4 file which disappeared. Okay, so for let me just merge it though, because finally we would like our main to be at the latest this thing. We would like our main branch to be updated, right? So we will merge all of these into our main branch. In order to be able to do that, first you're supposed to check out to the main branch. So I've merged both of my branches onto main. When I did git merge special feature while being on the main branch, if you notice it says fast forward because the main simply had to go from here to the head. The head was currently here, so it's like it's walking in a straight path. So main just had to slide from here to here. But if you look at new feature is somewhere off the track. It is not in between main and head. So this is the actual merging. From outside, it's coming onto this whatever you call this. Maybe you can try playing around by creating new branches, modifying the files, staging them, unstaging them, committing, resetting the commit, checking out the multiple branches, merging them, and all the other things, and keep printing the outputs of git tree, uh, git log, git status. So all of these are the commits that we did one by one. So this is the first thing we did. Then we did this. So you can uh, try working with these basic commands. So this concludes the basic Git workshop for the local repository. Now, after this, I will be telling you how to interact with GitHub from the terminal. So this is your local repository. On GitHub, you will have your remote repository. Remote because it's not on your device. It's somewhere. It's stored elsewhere. So we'll see how to deal with GitHub in a while.